What if we could take the ancient wisdom of nature and fuse it with cutting-edge technology to solve one of our biggest challenges? Feeding the world without wrecking it. It sounds like pure science fiction, right? But the solution might actually be hiding in plain sight, inside the leaves, roots, and stems of plants all around us. For decades, modern agriculture has pretty much run on a flood of synthetic chemicals. And yeah, they boosted crop yields, but they came at a huge environmental cost. But now, it looks like a new, greener revolution is starting to take root, one that's all about replacing those harsh industrial processes with elegant, natural chemistry.
So, let's break this down. On one side, you got the old way, chemical synthesis. It's often toxic, it burns a ton of energy, and it creates a lot of nasty byproducts. But on the other side, we have green synthesis. It's eco-friendly, it's sustainable, and it's powered by literally the most sophisticated factories on the planet, plants themselves.
And the need for this change is, well, it's urgent. Our current methods mean fertilizers are constantly contaminating our soil and water. Pesticides leave behind residues that build up all the way through the food chain. That's a process called biomagnification, where toxins just get more and more concentrated as they move up from tiny organisms to bigger ones. All this contributes to greenhouse gases and, tragically, it harms the pollinators we depend on. The old way is just, it's not sustainable.
And this brings us to the solution. We need to start thinking about plants not just as things we grow, but as these microscopic, super advanced factories. They are absolute masters of complex chemistry, and we're only now figuring out how to tap into that incredible power.
The core idea here is called green synthesis. Honestly, the easiest way to picture it is like making tea. When you steep tea leaves in hot water, you're pulling out all these powerful compounds, right? Green synthesis does something really similar. It uses plant extracts where these natural compounds do two key jobs. First, they help build tiny materials called nanoparticles, and then they wrap around them to keep them stable, all without any harsh synthetic chemicals.
So what's actually doing all the work here? Well, these are the heroes of our story. They're called secondary metabolites. And you've definitely come across these before. They're what give berries their deep colors or coffee its bitter taste. In the plant, they're used for defense. But in this process, they become nature's own microscopic construction workers, precisely building and stabilizing these nanoparticles. Okay, so how does a plant actually build a piece of technology? It's this incredible two-step process that happens at a microscopic level, combining total precision with natural efficiency. Let's get into it. First, you have the activation phase. Those plant metabolites are little construction workers, donate electrons to metal ions. This creates the first tiny seeds of a nanoparticle. Then comes the growth phase. These seeds start to merge, but the plant compounds surround them, acting like a cap that stops them from just clumping together randomly. This is what ensures the final nanoparticles are all uniform and stable. It's a brilliant example of nature's built-in control. All right, that's the science. But what does this actually mean in the real world? Well, with this powerful new tool, we could completely revolutionize agriculture, making it smarter, safer, and way more sustainable, from the farm all the way to your fridge. And the potential uses are just so diverse. We're talking about smart nanofertilizers that release nutrients slowly, exactly when the plant needs them. We can make targeted nanopesticides that protect crops with way less damage to the environment. We can even create nanobiosensors to detect diseases early and edible coatings that keep our fruits and veggies fresh for longer.
And the impact here could be absolutely massive. Get this. Right now, somewhere between 20 and 40% of all global harvests are lost to pests and diseases every single year. That is a staggering amount of wasted food, water, and energy. This plant-powered nanotech gives us a direct way to fight that loss and make our food supply more secure.
Let's just look at fertilizers, for example. As you can see from this chart, the difference in efficiency is dramatic. With conventional fertilizers, a huge chunk of it just washes away, polluting our rivers and groundwater. But nanofertilizers, because of their tiny size and slow-release coatings, get absorbed way more effectively by the plant. That means we get better growth with far less waste and pollution.
This technology also helps solve a problem we all face after the harvest. How many times have you had to throw out berries or lettuce that went bad way too fast? Well, these nanoparticles can be used to make invisible, edible coatings that create a barrier against moisture and microbes, which can dramatically extend the shelf life of fresh produce.
So, the potential here is clearly enormous. But let's be realistic. Making this the new standard for agriculture isn't going to happen overnight.
Just like with any powerful new technology, there are some pretty big hurdles we need to clear responsibly as we move forward.
First up is just scaling production. How do we go from a lab to an industrial level? We also have to make sure we get consistent results, because the plant extracts themselves can naturally vary. And most importantly, we need to do the long-term studies to really understand the ecological impact and set up clear safety regulations.
Look, getting this right won't be the job of scientists alone. It's going to require a massive collaborative effort. We need researchers, industry leaders, and policymakers all working together to navigate these challenges and make sure this tech is developed in a way that's safe, effective, and truly sustainable.
So this all brings us to a final, really fascinating question. For years, we've been looking to sterile labs and complex machines for the future of food. But what if the most powerful, precise, and sustainable factory has been here all along, quietly perfecting its chemistry inside every single leaf?